runs on Ethereum. And I think, yeah, this is a very technical audience, so we'll just say like exactly what it is under the hood. So what it is, it's an open source stablecoin wallet. It takes advantage of a lot of these really nice things that have made Ethereum a lot better recently. So if you wanted to make something that kind of feels like Venmo but works everywhere, like a global Venmo, even a year or two ago, I think it would have been very hard. But now rollups are getting good. Account abstraction is kind of mature and has some infrastructure around it. This thing called proto-dank sharding, EIP 4844 is landing really soon, which is going to make rollups even cheaper. As a stopgap, until then, we're just using a paymaster to subsidize transactions, so you get free transfers. It runs right now using USDC on Base, and then we're going to support other coins, other chains in the future. But yeah, what we're about to show you, if we can get this stuff to work, fingers crossed, is our on-chain Venmo. Let's try that. Say quit. Daimo. Perfect. Okay, this is very slow. Let me do one thing, sorry. I'm about to make this guy A. That's more like it. Okay. All right, perfect. Okay, this is almost visible. Nice. So, yeah, this is the home page. This is actually, okay, funny story about this. We have not built any kind of desktop app. We built this as a mobile app using React Native and Expo, and so it runs on iOS, it runs on Android, and it turns out we found out about this right after we got into the App Store earlier this week. That, hey, there's a button that says install on Mac, like what does that do? And it turns out that Mac actually has really nice like iOS app emulation built in. And so this is just an iOS app that like runs more or less functioning on desktop. We're gonna clean it up so that the desktop experience is like as good as the mobile one. But really lucky because it lets us show what we're doing. So, okay, deposit, you can on-ramp from Coinbase, you can on-ramp from anywhere else as long as it's USDC on Base. Let's do this. I can send to anyone. I'm going to send Nolan. And let me actually get on the network if I can. I'll just tether to my phone here.
There is Wi-Fi.
Oh. Damn, 2016 1. Okay, cool. And I'll send 42 cents because that's a nice auspicious number. Confirm and send. So this is going to ask me for my auth. We can talk a bit about how keys work. Actually, do you want to say a bit about how keys work in Daimo?
Sure. Yeah, so with account abstraction, we're actually not using like a standard EOA style key. Instead, it's one of the keys that's secure enclave keys. So it's locked to your hardware. So for Macs, they have this built in with Touch ID. With iPhones, it's Face IDs. So that authenticates that this key that lives in your hardware never leaves your device, never can be seen in plain as the private key. So there's no seed phrases, nothing of that sort. It's signing the message for the transaction that DC is sending and putting that on chain. I don't know if you want to show the on chain.
Yeah, for sure. So a little more I could say, but basically modern phones have something that's a lot like a ledger built into them. Apple calls it the secure enclave. Android calls it key store. 4337 account abstraction lets you use it in an Ethereum wallet. So that's what we're doing. And then under the hood, it appears really like clean. The user just sees it as an add device, remove device flow. But each of those devices has a hardware locked key, just like a ledger would. So yeah, easier self-custody, and it's really nice and secure that way. So then if I click on this guy, you go to base scan. So you can see this is an actual on-chain USDC transfer that just happened. Mm-hmm. So I'm going to show one other thing that is fun. So let's say I want to send Gigi or Gigi? How do I say it right? Gigi, perfect. And she doesn't have an account yet, maybe not any Ethereum account altogether. So I'm going to send a link for, let's pick another lucky number. That. So this creates a payment link. And a payment link under the hood is a burner wallet. But it shows up in this really nice way. So basically, this is a link now that is basically a bearer asset that it's like a cashier's check, where whoever I send it to can redeem it for $7. So I will say copy. I'll go to Telegram.
Are you actually sending us something?
Yeah, absolutely.
Why
not?
And I don't have to send it back, right?
No, it's yours. But
Oh, yeah.
okay, perfect. Found it. Wow, I really made my screen tiny. Now I made it so tiny that Telegram is broken. Okay, it worked. And then, yeah, I guess I can't cast this part, but so Gigi's going to be able to redeem that, and it should just work.
So how does this work under the hood, like a burner wallet?
Yeah, so the way it works is it actually sent 7 USDC to a contract. It worked? Okay, perfect. To a contract on Base. And the, let me see if I can pull it up in Telegram here so you guys can see it. Aha, perfect. Okay, so this URL, the hash portion of the URL, which by the way, never gets sent to a server, URLs are nice that way, is the private key for effectively an EOA that owns those $7 until Gigi claims it. And so it just exists in this note. If I sent it to someone and they just never claim it, I mean, I can reclaim it myself. I still have that same key, and otherwise it's just whoever I send it to can claim it on their end. But the really nice thing about it is it lets you do what all of these different fiat apps, Zelle and PayPal and Venmo and so on, do, but all sort of permissionless, self-custodial, and on-chain. What all apps let you do is they let you send money to someone who doesn't have the app yet, and then they can claim it by installing the app. And then in our case, of course, part of what permissionless means is you don't specifically have to install Daimo, right? Like if I grab the same link and I were to go here.
This is claimed already, right?
It's claimed already, yeah. Perfect. So this is what it would look like, on the web, and then it says there's the place where you could get the app. If it wasn't already claimed, then you would also see a button say, like claim with any wallet, and that's just a connect wallet button. You could claim it to Rainbow, MetaMask, anything else. So it's all an interoperable system. So let me say one last thing, and then I'll wrap up here. So let's do the traditional. I'm going to send Vitalik.eth. Let's actually send it to Ansgar.eth. That's our friend Ansgar Dietrichs, and we'll send him 42 cents. Perfect.
So these are all on-chain, right? On-base chain.
All on-chain. And so you can send it to someone else by their Daimo username, which is also, by the way, an on-chain name registry. But you can also send to ENS or just a bare Ethereum address. Yeah, I think that's all we've got. Do people have questions?
So can you explain what burn wallet is?
I shouldn't have used the word burner wallet. I was just using it as an analogy to explain how the payment links work. I'll just say exactly how they work, sort of first principle. So
I think you can use a web word.
no, I'll just say it. So if I want to send you money, but you don't have an Ethereum account yet, what address do I send it to?
Okay.
And so what a payment link is it, actually, let's say it very precisely, it sends it into a contract on Base that holds all of the current pending payment links. And so like I'm transferring 7 USDC into that contract. And the way that the contract works is that anyone who can sign a message with a particular Ethereum EOA can claim that $7. And then how do I get that Ethereum EOA to you? It's just in the link. So the link is basically, the main part of the link has the address, which is an Ethereum address, is a hash of a public key. And so that's what lets the server show like the status of the note, being like, yep, it's a $7 note, it either is claimed or isn't claimed, all that stuff. And then the hash portion of the address, which never gets sent to the server, is the corresponding private key. And so when you tap on that on your side, it opens in-app and then you can claim it.
So how does the contract look like?
What was that?
How does the deposit contract look like?
You can pull it up.
I mean, yeah, I can send it to you. It's actually a really small contract,
Yeah.
and it's pretty like well documented. Like it's a good like starter learning Solidity contract if anyone wanted it for that purpose.
Just to check the signature, I think, yeah.
Yeah, exactly. Basically, it has a map of like, address that is all of the current pending notes, and then it has a claim function that you give it a signature from one of those addresses, and it gives you that note and marks it as claimed.
Oh, you don't deploy a new contract. There's a deployer.
Precisely.
Okay.
So what we could have done potentially is literally just like sent it to that EOA on chain instead of sending it into the ephemeral notes contract. The annoying thing about that is that on the other side, when someone wants to claim, like in order for that EOA to like send you USDC, it has to have some ETH in it as well to like pay the gas. It's all a mess, right? And so what we do instead is we just like put it into this notes contract that encodes the correct logic.
So if the key that allows you to like spend funds is to the secure enclave, how do you remove the need for another seed phrase or a backup mechanism if, for instance, I lose my phone?
Yes. Yeah. Oh, that's a very good question. So there's 2 things. Actually, do you want to do that one?
Sure.
Yeah.
So there's 2 parts to it. So one part is you can add multiple devices. So, well, DC already showed we have an upcoming Mac app, but iPhone and Android will have apps, so you can add multiple devices. But the second part that we're more excited about, which we haven't released yet, but hopefully by next week we'll have support for passkeys. So there's 2 types of like sort of keys that exist in this Web 2 world, which is one is like the secure enclave device locked hardware keys. So those never leave your phone, never can like even touch your RAM. But the other type, which is passkeys, are actually backed up to iCloud Keychain, Google Password Manager, whatever it is. And those are like already like websites like Coinbase and everyone uses them for login. So those keys will be backed up and you can add a new backup key to your account.
Quick show of hands. How many people here have ever used passkey login?
Okay.
About half. Okay.
Not sure what it is exactly.
What was that?
Not sure what it is exactly.
So it's interesting. Passkeys are very new. They're what Apple calls WebAuthn, if you've heard of WebAuthn.
Yeah, probably.
But I think that like both Apple and Google are like pushing them pretty aggressively, so I think they're going to be quite common quite soon. What they are is primarily what passkeys are is a replacement for passwords, and a replacement for text passwords that get saved to a password manager. So instead what happens is a passkey is a cryptographic key pair where all of that's neatly hidden from the user and the private key is saved to a password manager, and it's generally the one that's built into your device, which is iCloud Keychain on your iPhone or Google Password Manager if you have an Android. And what's really nice about it, it just has better security properties than passwords do in general, and there's less extra steps involved. It's just you sign in to any site that supports passkey sign-in, you're signing in by signing a message versus by sending the secret like you would with a password login. The great thing for, Ethereum wallets that use account abstraction is that you can repurpose this passkey login mechanism as a signing key mechanism. And so you have this thing that has hardware support as well as like infrastructural support from Apple, from Google for like secure backup, and use it as a signing key on your Ethereum account. Yes, yes.
It also kills phishing. So
Yes.
if you use passkeys the way login works, the origin has to like ask for the credential.
Yes,
So you can't
exactly.
have, like it couldn't be like Coinbase with the weird service
Yes.
key and like you log into that instead. So
Yes.
It actually kills phishing completely.
Exactly. It's like a different domain literally cannot request like the passkey for that first domain. So if you have like paypal.com.info, then you can't, like you can make something that looks just like PayPal and asks them for their PayPal password and they might enter it. You could make something that looks just like PayPal and asks them for a passkey, but you would only ever get the .com.info passkey. The browser will never sign a message with the .com passkey. If that makes sense.
And so the R1 curve signature, how do you verify it on chain? Is it like a contract in Solidity, or do you verify
Yes.
it in the snark for succinctness, or no? It's purely
Not a snark, but directly on chain. But yeah, you can say about that.
Yeah, it's a pure contract, and yeah, we have like a blog post for P226 verifier as well, which may be interesting to people.
What scheme is this?
Say that again?
What signature scheme is this?
Sec P226 R1, so it's almost the same as the regular Sec P226 K1, but the curve is slightly different params.
Okay.
One,
But
one really funny thing that I think is not very widely known, even inside of crypto, is that so basically Bitcoin uses a elliptic curve called Sec P256 K1, and Ethereum also uses that. Every Ethereum EOA is a K1 key pair, and the EC recover like precompile, it uses the K1 key pair for all of that stuff. The entire rest of the world uses a very similar curve called Sec P256 R1, and by that I mean passkeys, secure enclave keys, key store keys on Android, YubiKey, like the entire rest of the like consumer crypto universe runs on this like slightly different curve. And so for the longest time, you couldn't do any kind of crypto account using standard consumer crypto systems. You had to do bespoke stuff like what Ledger does or what Trezor does, right? Because like the Ledger built into your phone only supports this R1 curve. But with account abstraction, you can put an arbitrary signature verifier that's arbitrary contract logic. And so that's what we've done for demo. So that's the situation there. Actually, question. Is there anywhere where you can post a link? Because, yeah, if you guys, we would love to like post a link to the app and we'll send everyone here a starter $5 if you guys are up for it.
I think most of us
nice.
Okay, if anyone doesn't, let me know, and I will just do it to you manually. That's great. The other thing I was going to post, someone had a question about the payment links contract. We can post.
Well,
that.
you guys are already in our group chat. I've just did that.
Okay.
So
I'll post it there. Easy.
Anything fun there.
Deal. And yeah, if people have any last questions, I'm down.
all transactions happen on the layer 2 blockchain. So is there any native token needed for initiate a transaction like Ether? No?
That's a great question.
Yeah,
So
that's what I wanted to ask.
So okay, so actually, this is a really good thing to talk about. So I think account abstraction solves like 3 really sort of blocker user experience issues, and one of them is exactly that. So basically, okay, so the one that you're talking about is with traditional EOA wallets like Rainbow or MetaMask. If I want to have some USDC and send you that USDC, I also have to load a bit of ETH to pay the gas fees. So you have to like side load an additional asset to the one, and if you run out of ETH, then you have to get more ETH, and until then your USDC is stuck and you can't send it. It's a bad situation, right? And so account abstraction solves this with a mechanism called paymasters, which is the exact details of how it works is a little in the weeds, but the long story short is it decouples who is paying the gas from who is doing the transaction. And it's not necessarily it decouples and it's the paymaster can be an arbitrary smart contract, so it can even do nice things like, say I am sending you 10 USDC, and I pay $10.05, and that last 5 cents is going to the paymaster for gas, and then the paymaster is paying in ETH what the gas is. So that's one of them. So yeah, basically account abstraction solves like gas in this really nice way with paymasters. It solves the fact that being able to support other signature types so that you can use like widely deployed consumer crypto systems like the iCloud keychain to secure your account. And then the last really important problem that it solves is key rotation. So an EOA, traditional like crypto addresses are permanently tied to a specific secret. That is your seed phrase, for example. And then if you ever lose that, or if someone else gets it, then that account is permanently compromised. And with account abstraction, you can do what sort of the rest of sort of cryptography best practices does, which is you don't have like permanent secrets. You have every secret is something that can be rotated. And so, for example, in Daimo, like I can add, I've added my phone to my account and my computer to the same account. That's what I was doing the demo from. Then if I lose my phone, I can just go to the computer and kick it off of the account. And it's an on-chain transaction that removes that as a signing key from the contract wallet. Does that make sense?
Yeah.
So yeah, AA solves all the problems.
So is my Daimo account in a account abstraction wallet?
Exactly. Every Daimo account is a contract wallet.
Are you paying for all the gases that you spend?
Yes.
Wow. It's a gasless wallet.
It's a gasless wallet. It is.
Oh.
So it's interesting. Right now, that is like, it's not really expensive, but right now it costs us on the order of like 40 cents maybe every time someone makes an account, and then maybe 10 cents every time someone sends a transfer. But the reason we're willing to do that is because 4844 is coming really soon, which is going to probably reduce that by a factor of 10 on both of those. And that makes it cheap enough that it's sustainable. Yes, sir.
I just did your device ad, which is really cool. Are you doing multi-sig? How do you do the multi-device? Like, where is there one signing key, or like how does that work?
Every device has its own signing key that never leaves the device that it was created on. That's, by the way, another thing from like rest of cryptography best practice. It's really good to have, like, for example, if you do SSH, like the recommended way, you permission each like device that's allowed to log in. You're not like copying the SSH private keys around or like saving them as a seed phrase or something. And so this works the same exact way. It's like every device has its own signing key and gets permissioned onto the account.
So who decides though that like my account name is Mac? So you guys create this new identity for me, Mac, this username, and there's devices linked to the username.
Precisely.
How do you trust that? How does his Daimo know that my Daimo is telling him the right list of devices?
That's an excellent question. The name registry is on-chain.
Okay.
So at the time of account creation, you are claiming a name on-chain.
Mm.
And actually, one thing, you can think of it as just an ENS name, and in the future it might literally be. So basically, if you have like, Mac, for example, we could retroactively make it so that that's mac.daimo.eth under the hood. The only reason we haven't done that yet is because of some like plumbing and wiring to do like the ENS subdomain delegation to L2 thing. But it works the same basic principle as ENS in that it's an on-chain name registry where you can go claim your name.
So each phone has a different Ethereum address?
Not quite. So Mac is going to be one Ethereum address, but it is the address of a smart contract. So that's like what an account abstracted, basically the old style of like crypto account, which I consider like legacy settlement infrastructure right now, right? Is like you have an on-chain address and it's tied to a key pair. It's tied to like an address that you saved somewhere. The new style, which is like account abstracted accounts, 4337 contract accounts. You have an on-chain address and it corresponds to a smart contract. And that is your wallet. And so basically, if you like add 2 or 3 devices, that it's not the case that each one of them has its own Ethereum address. Each one of them has its own signing key, but they all share one address.
So the contract has logic for what are the device keys.
Okay, because the link, when I do like receive on each different device, it generates like what looks like URLs with Ethereum addresses at the end that are different per device. But those are just UUIDs or something?
Exactly.
Okay.
Exactly.
Or online
Those are request IDs. So
Yeah,
that all that
correct.
is it's bookkeeping for whether that particular request has been fulfilled or not.
Oh.
The important part of those two links that is the same. So you'll actually see it'll say daimo.xyz/link/request/Mac.
Yeah.
And that Mac part is a lookup into the on-chain name registry. That's the destination for that
Ah, okay.
request, and it's the same on both devices.
Cool.
And then even if you on the same device, if you create 2 or 3 requests, you'll see each one of them has a different request ID because they get tracked separately whether they've been fulfilled yet. Yeah.
Cool.
Sweet. This is really good. You guys have more in-depth questions by far than anyone else we've shared this to. Most people are like, oh, this is really fast. No gas. Yes.
What's been the merchant feedback so far?
Well, we got into the App Store on
No, it's
Sunday,
using a
Monday?
cafe here, right? At
Manoa. Yes.
Are they giving you any feedback yet about using it?
Good question. So we're getting the Manoa set up with it. We actually have a session with them at 4 p.m. today to onboard all of the waiters. So I'll let you know.
So cool. Awesome.
One other fun thing, speaking of vendors, by the way, that we haven't done yet, but the same request mechanism with a request ID for tracking is usable for online checkout. So how many of you bought a zuconnect ticket through the zuconnect online checkout? For how many of you is that a fun experience? Yeah, you seem really sad about it. I have yet to see a pay with USDC online of any kind that wasn't pretty rough. And it has all of this back and forth, especially if you're on a phone where it's connect wallet, swoops you over to Rainbow, you get a spinner, go back to the site, allow all for USDC, back to Rainbow, confirmation prompt, confirmation time, back to the first app, and you bounce back and forth a couple of times. So what you could do now even actually is just generate a request link on a website and say whatever, check out with USDC, someone clicks that link. If they have Daimo, it'll just open directly in the app and then they have one button tap to pay it. And you can see that it was paid because it matches the request ID. And if they don't have Daimo, it goes to that website and they can click the connect wallet button and pay with any other wallet. So that's one thing we're working on. So we might have some not in-person vendors to tell you about next time we do this.
Cool.
Sweet. I don't want this to be a 6-hour demo day, so I think we're good.
Is it just you two with me?
Just the 2 of us. We've been working on it since June.